Hello everyone, today in this video we'll be discussing about the module 1 of DDCO, which is Introduction to Digital Design. And this module can be divided into 3 topics which we'll be discussing in depth. What are the important questions you need to know, the important concepts, how do you remember, and if you watch this video till the end, it will be sufficient for you to score more than 80% marks in the exam. Before starting, make sure you hit the like button, subscribe to my channel for more videos like this. Now let's get started. So the first topic we have is the Boolean functions. Okay, so what is the meaning of Boolean? Okay, Boolean means either of 0 or 1. Okay, it can be a binary value that can be either 0 or 1. Okay, so that is called as a Boolean value. So 0 means as false and 1 means as true. Okay, and bear with me, I'll be explaining you with examples. And before that, a few concepts are there, like what are the gates and all. Okay, so there are three logic gates. Okay, and those are not and or. Okay, so what is a not gate? If x is equal to 1, then not of x is equal to 0. See, I told that binary value could be either 0 or 1, right? So that can be stored in a variable. Okay, like suppose I store it in a x variable. So what will be the value here? It can be either 0 or 1. And if we take a not operation, this is the operations you're performing. Okay, so when we perform that operation, not operation of on x will perform, then it will become not of x is equal to 0. If we perform an and operation, we have to take two variables and the value of two variables will be and. Okay, if you do the AND operation, the answer will be here as 0. Why it is 0? See, the answer will be 1 only when it is both are 1. Okay, if both are true, then only the answer will be true. In all other cases, it will be 0. Okay, that is how the AND operation works. Next, we have the OR. In OR, either of them should be 1. Okay, either of them or both of them should be 1, so it will be true. Okay, so in this case, since x is 1, OR of x and y is equal to 1. It will be 0 only in the case where both are 0. Okay, none of them are 1. In that case, x or 0, x or y will be equal to 0. Okay, so this is about the logic gates. So how many were there? And, not, or. Okay, and Boolean value can consist of 0 or 1, the values in it. Now, what is a truth table? Truth table is a table that shows the possible input values and their output values for the gate or logic. Okay, for example, if I tell you the truth table for the AND gate. Okay, what is a truth table? We'll be first having here 0, 1, 0 and 1. Okay, so here I'm putting it as 0, and here if I put as 0, that means the value is 0 here. For 1 also the value is 0 here. Okay, so if both are 0, if this is also 0, this is also 0, then it will be 0 itself. Okay, I can make it in a more better way. Instead of writing it as 0 1 and 0 and 1, I can take it I can take here it as x y, x and y, right? So if x is 0 and y is 0, then x and y will be 0. If x is 0 and y is 1, since one of them is 0, the final answer will also be 0. And if x is 1 and y is 0, then this will be 0. And if x and y both are 1, then in that case only the final value will be 1. Okay, so this is called as a truth table. Okay, now logic gates can be represented in the form of circuit diagrams. Okay, that's very important. We have to represent these in the form of a circuit diagram. Okay, so how do we represent in the form of circuit diagram? As you can see here, x and y are the inputs present. Okay, x and y are the inputs present here. This is the input, this is an input, and here we have an AND gate. AND gate is represented in the form of a D. Okay, and the final value will be z is equal to x and y. Okay, and OR gate will be represented in the form of wedge form here. Okay, like this, a curve form here. So x and y will be present here, x or y will be equal to the output. Okay, and x is present here, the NOT gate will be represented in the form of a triangle here with a circle at the end. Okay, so that will be x naught. Okay, now there are few basic theorems and properties of Boolean algebra. So x plus 0 is equal to x into 1 is equal to x. Okay, like normal maths. X plus x dash is equal to 1. Okay, if you take x and if you take the naught of that and do the OR operation, at that time you will be getting 1. Okay, let's take an example. If x is equal to 0, x bar is equal to 1. Okay, so what is 0 or 1? 0 or 1 will be equal to 1, right? So that is the not operation. I mean the OR operation on the inverse of it. Here we have the AND operation on the inverse of it. So x and x bar will be equal to 0. Okay, and here we have x plus x. This is the adding the same thing. means doing the OR operation on the same thing, we will be resulting that same thing. If you do the AND operation on the same thing, we will be resulting the same thing. If it is 1 and 1, it will be 1. If it is 0 0, it will be 0. 0 and 0 will be 0 here. And x plus 1 is equal to 1. So no matter what the value here is, if you do our OR operation with 1, it will become 1. Why? Because the since the OR operations result will be 1 only in case when either of them is 1, right? So since this is sure that this is 1, no matter what this is 0 or 1, the answer will be 1 here. And the AND operation on both of these x and 0, that will be equal to 0, because it's a compulsory condition that both of them should be true for this to be true. Since this is 0, we are sure whatever the value here it's present doesn't matter, this will be 0 only here. Next we have the not operation on the not operation. Like suppose you take x is equal to 0, what is x bar is equal to 1? If you take the x bars bar, it will be again 0. That is equivalent to the first one which took x is equal to 0. X plus y can also be written as y plus x, same xy is equal to yx. Here is the associative x plus y plus z, means do the OR operation on this first, then do the OR operation on this. That is equivalent to do the OR operation on these two first, then this. The equivalent is present here for the AND gate. The distributive law, x into y plus z is equal to xy plus xz. This is simple maths here, and here the same thing goes here, but it's a bit confusing. Okay, here the multiplication is there, so we are going to easily figure it out. But here what's the case is x plus yz is there, so what you'll do, you'll do x plus y into x plus z. Okay, x plus y into x plus z. And here what we have, De Morgan's law. This is a very important concept, also listen carefully. Here we have x or y the bar. Okay, and when we remove the not operator here, what will happen is it will change the sign of x and y, and it will change this to AND. Okay, what I am trying to explain is that, see, you have x here and you have y here and you have plus here. Okay, let me put the normal mode. Okay, see here, this is x or y. Okay, and a not gate is present here, means the not operation of this. Now we have to convert this into by using De Morgan's law. What does it state? It states that change the state of every operand. With x you have to write it as x bar, and y you have to write it as y bar. And since this is an or operator, it will be converted to AND operator, and these both will be these both will be equivalent. Okay, so this is what the De Morgan's law is. The same applies for the AND also. Okay, so how it will apply for the AND gate? In AND gate you have x and y, and here we will be having a bar. So convert x into x bar and AND operator to OR operator, and y will become y bar. So these both are equal. Okay, this is what it is written here. Okay, so these are the few things in the De Morgan's law. It's very important, and it's applied very widely while solving the problems. Okay, the numerical section. So let's have a look at the last law, which is the absorption law. So what it does, it absorbs. Okay, here we have x or xy. So since x is a majority, here the answer will be x, and here also x and x plus y. So since x is majority here, you need to remember that it is x only present here. Okay, next we have Boolean function. So what all you had just seen, that is the properties. Now by using those properties, we will be writing some equations that is called as Boolean function. So it is an algebraic expression that consists of binary variables and Boolean operators. The combination of two things. The first is the binary variables and the operators associated with that. If you write it in a form of like this, f is equal to, then it will be a function. Okay, so Boolean functions could be transformed into circuit diagrams. Okay, so this same thing can be written in the form of a circuit diagram. You remember initially I had shown you how the circuit diagrams look. See, this is the circuit diagram. So if you want to represent AND gate, you'll be using like this, OR gate will be represented like this, and NOT gate will be represented like this. Okay, so let's have a look, how do you represent this function in the form of circuit diagram. Okay, so x bar, first take all the inputs. Okay, what are the inputs? We have x, y, and z. So take x, y, and z in the natural form. Then we have here x bar, right? So we have to take a NOT gate and make x bar here. Okay, and here we have y bar and z. So two things you have to do. First convert y to y bar, and convert means z is remaining same here. And what is the operation happening in between y bar and z? It is AND operation. So we'll be using an AND gate, and we'll be getting these two terms here. What's happening in between them? the OR operation. So these two will be given to a OR gate, and that will be the final F1. Okay. The next topic we have is the digital logic gates. Okay, so since we have seen the three type of gates, AND, NOT, and OR, there is another type of gate as well, which is the NAND, NOR, and XOR. Okay, these three are the new gates for you. So here what we are doing is we are taking the NOT operation on AND, NOT, and OR gate. Okay, sorry, not on NOT. There is a special gate which is XOR gate. We'll be discussing what it is. Okay, so like a summary for all the gates, what is the circuit diagram, what is the formula, what is the truth table, that is given here. Let's have a look at them. So for the AND we have X and Y here, and operation the circuit diagram for AND gate is like a D, and this is the output. Okay, this is the input part, this is the output part, and it will be written as F is equal to X dot Y. So AND will be represented by a dot. Okay, and the truth table is as follows: X and Y are present here. This is F. So in AND gate the condition will be true when both of them is 1. Okay, so since this is 0 here, it will be 0. Since this is 0 here, this will be 0. And since this is 0 here, this will be 0. Since both are 1 here, this final answer will be 1 here. Okay, the OR gate will be as follows. The design is like this, and here we have the inputs and here we have the output. F is equal to X plus Y, and X and Y are given here. If both are 0, it will be 0. If either of them is 1, it will be 1. So these three cases, at least one of them is 1, so the final answer will also be 1. Okay, next we have the inverter. Here it is F is equal to X dash. If the input is 0, the output will be 1. If the input is 1, the output will be 0. The buffer is the thing where it remains same, but the circle is not here. Okay, as the NOT gate, and the answer will remain same. If it is 0, it is 0. If it is 1, it is 1. Okay, and here we have the NAND gate. NAND gate, what's happening, the reverse of AND gate. Okay, first we'll take the normal AND operation of this, and whatever answer we get, we invert it. Okay, like for example, if X is equal to 0, Y is equal to 0, what is the answer here in AND gate? If X is 0, Y is 0, the AND operation will also be 0, and we'll take the NOT of this one, so it will become 1. So when both are 0, the answer is 1. Okay, just make it very simple. Whatever the answer you are getting here, right, reverse it. It is 000 and 1. Here what you will be writing, here you will be writing 111 and 0. Got it? Just make where it is 0 as 1 and where it is 1 as 0. That's very simple. And or also it's same, whatever answer you get and or here, just reverse of it. So it is 0111. Here it will be 0. In our operator we will be having 1000, where it was 0111, right? Here also the same thing. If either of them is 1, in that case the OR operation will become 1, and then you will take the NOT of it. Okay, so if either of them is 1, the answer will be 0 here. Okay, see, either of them is 1, the answer is 0 here, because we are taking the inverse of OR gate. Okay, and this is the exclusive OR gate. This is also very important gate here, which is the exclusive OR. In exclusive OR, what happens, it's same as the OR gate. Okay, first remember this, it's same as the OR gate, but one difference is that it's exclusive OR. Exclusive OR means if only one of them is 1. Okay, if only one of them is 1, then only the answer will be 1. If both of them is 1, it's not exclusive, right? Exclusively it should be true, means one of them should only be true, both of them can't be true. Only if one of them is true, the final answer is 1. Else if both are 0, it will be 0. If both are 1, it will be 1. Just take the inverse of this, you will be getting the exclusive NOR gate as well. Okay, here it is, if both are 0, it is 1. If it is both are 1, it is 1. In rest of the cases where at least one of them is 1, the answer will be 0 here. Okay, so these are the very important gates which we will be going to use in forming the circuit equations and the truth tables and simplifying the expressions and many such questions. Okay, so this is like an introduction for the problems. Okay, next we have a very important concept, which is the K map. Okay, this is very important. So let's discuss it very slowly and in depth. Okay, so let me write it. It's a very important question. Okay, it's a short question from the exam point of view. In all the exams it has been asked. Okay, K map. So what is a K map? Okay, it is a 2D table. Okay, it is a 2D table with rows and columns, and here you can see I have written as M0, M1, M2, M3 and so on. Okay, so these are the numbers of the blocks. So each of these block has a number which I have written here. Okay, and here we have added some variables also. Like for example, if there is 2 cross 2 I mean 4 cross 4 matrix then we can add two variables here and two variables here. Okay, so it is wx and yz here. Okay, you can take any variables, and he will be writing the numbers. Okay, like 0 0, like we are writing the combinations of w and x. Either w and x can be 0 or 1, right? So what are the combinations that can be there? 0 0 0 can be there, 0 1 1 1 and 1 0. Here one thing you can observe, that in the normal codes, when we write, right, what happens, we'll write 0 0 0 1, then we'll be writing 1 0, then we'll be writing 1 1, right? But here we have done the reverse of it. Here I have written 1 1 then 1 0. Why is that? Because this is called as a gray code. Okay, what does gray code mean? Gray code means only one of them can change. Okay, since it's 0 0, only one of them can change. So this has changed, again one of them can change, this has changed, again one of them can change, so this has changed. We cannot change both at the same time. Okay, we cannot change both at the same time. So this is how you will be writing the rows and the columns which is present here. So you will be writing 0 0, then you will be writing 0 1, then you will be writing 1 1 and 1 0. Okay, so in the case you write 0 0, then 0 1, then you write 1 0. Here see, both of them are getting changed. 0 is changed to 1 and 1 is changed to 0. That will violate the gray code. Okay, gray code says that you cannot change two things at the same time. Okay, so that's why we are writing 1 1 here instead of 1 0, then we'll be writing 1 0. Okay, same thing goes here also, 0 0 0 1 1 1 and 1 0. Okay, and here we are writing all the combinations which are seen. Okay, what are the combinations which are seen? So as you can see, here we have the w x y z. First we will be writing w x y z. Okay, that's the first rule. In every cell we will be writing w x y z. Now based on the value, if it is 0, we'll be writing a bar like this. If it is 1, we'll be writing it as such. Okay, now let's have a look at few of them. Here we have 0 0 0 0. So w's value is 0, x value is 0, y value is 0, z value is 0. So every of them will be having a bar at the top. Okay, if it is this case, everyone will be having a bar except the last one, which is z here. So z will be normal. If we take this case here, both of them is 1, which is 1, y and z is 1, so y and z will be written as such, and these both are 0, so it will be written as bar at the top. Now take a random one here. Okay, take this one. Here it is 1101. Okay, for this one it is 1101. So 11 means wx will be written as such, and 01 means y will be here as bar, and z will be 1 here. Okay, so this is how you write in terms of the variables, the in terms. Okay, now there's a question here. So this you can expect in exam, like this kind of questions where you will be given a Boolean function and you are supposed to solve it using the k-map. Means you have to arrive at an equation. Okay, the final answer will be an equation. Okay, finally you have to arrive at an equation, that is f is equal to something. Okay, so this is how do you arrive at this? By using the k-map. Okay, so the first step will be to create a 2D matrix. Okay, so here, since how many variables are there? 4 variables are there, right? So it's very simple to know how many values will be there. 16 values will be there, right? Because each of them can be 0 or 1, so it is 2 power 4. Okay, 2 power 4 is 16. So for the 4 variables you will be creating a k-map, something like this. Okay, so you just draw a square here and divide it into the 4 columns and 4 rows. Okay, after that you have to write here as x, what are the variables? W x y z, right? First two variables come here, next two variables come here, and here you will be writing it using the gray code. It is 0 1 0 0 0 1 1 1 and 1 0. Okay, the same thing goes here as well, 0 0 0 1 1 1 and 1 0. Okay, after that you will be writing the terms here. So first you will be writing 0. So let me explain you how you will be writing the m values. Okay, so m values should be written as follows. So here you will be writing as m0. Okay, m0 and m1, and here you will be writing m2. Okay, because of gray code it will differ a bit. Okay, now observe why I'm writing it as m2 here. Okay, see what it is written, 0 0 1 0. Okay, for each of these values you have to convert into the numbers. Okay, so it is 0 0 0 0. Okay, what is 0 0 0 0? It is equivalent to 0, and here we have 0 0 0 1. Okay, so 0 0 0 1 will be equivalent to 1, Here we have 0 0 1 1. Okay, 0 0 1 1 is the equivalent in the decimal form is 3, and here we have 0 0 and 1 0 for the last one. Okay, this is equal to 2. So based on this coding we have to write the values. Okay, so this is how you will be writing these values. If you are confused about how we get these values, so it's very simple here. Let me explain that. So firstly, if you want to convert the decimal values into the binary values, what you have to do is first write the decimal values here. Okay, 0 1 2 3 4 5 6 7. Okay, by you till if you want to write till 7, you have to use three variables. Okay, three boolean values. So I'll be starting with zeros. Okay, first write 4 times 0. Okay, 4 times you'll be writing 0, and then 4 times you'll be writing 1. Okay, in the second part you'll be writing 2 times 0 and 2 times 1, again 2 times 0 and 2 times 1. Okay, in the third part you'll be writing 0 1 alternatively. Okay, you observe the pattern. We are reducing it one by one. Okay, we are first doing 4 times 0 4 times 1, then it 2 times 0 2 times 1, and 1 times 0 1 times 1, like that we are dividing by 2 every time. Okay, so this is how you get the equivalent of each of these decimal values. And if you want to do it for the till for the 16 values, like from 0 to 15, the same thing. What you have to do, you have to take 4 columns and write 8 times 0, then 8 times 1, then for the following 4 times 0 4 times 1, then 2 times 0 2 times 1, then 0 and 1, as like this. Okay, in that case you will be getting 16 values from 0 to 15. Okay, so this is a little bit information. Based on this coding we have to write these values here. Okay, so I'll be telling you one trick, so you have to remember it. What is the trick is, you'll be writing here 0 1, then 2 3. Okay, then here you'll be writing 4 5, then here you will be writing 6 and 7. Okay, you will be inverting the last two. Okay, the third one you will be changing. Okay, this will be applying for the rows as well. Okay, so very simple. 0 1 2 3 4 5 6 7, and then here you will be writing 8. Okay, not here. Here you will be writing 8 8 9, then here you will be writing 10, here you will be writing 11, and then normal 12 13, here you will be writing 14, and here you will be writing 15. Okay, so this is how you mark the values. Now, so for whichever value it is given here, for that value we will be marking it as 1. Okay, see, 0 is given here, which is the 0 value, m0. Okay, so since it is 0 here, it is m0 here, I will be marking it as 1 here. Okay, that is true. Okay, and here it is 1, so m1 will be 1. Here it is 2, so it will be true here. For 4 we have to write it as 1, so let me erase it. This will be writing it as 1, and here we have 5, we'll be writing it as 1 here, and here we have 6. For 6 also we'll be writing it as 1, and we have 8 and 9, so 8 and 9 are present here. 8 will be 1, 9 will be 1, and here we have 12. 12 will be 1, and here we have 13. 13 will be 1, and here we have 14. 14 will be 1. Okay, so after marking all these as ones, you have to erase this one so as not to cause confusion. So till you write it, you will be having to write the m values here. After that you can erase it, your wish, or you can keep it as well. The erasing is better because it will not cause confusion then, right? So once you erase these values, you'll be having a clear view of the K map. This is called as a K map. Okay, where you have the values marked, which is true and which is false. Okay, so here we'll be writing drawing a line. Okay, so the rest of the values just fill it with zeros. Okay, so to fill it with zeros, I'll be doing with a different color. 0 0 0. It's not required actually. Okay, so you have obtained the K map here. Okay, now what you have to do, you have to form the groups. Okay, so groups can be either a group of 1, a group of 2, a group of 4, a group of 8, or a group of 16. Okay, so this is how you form the groups. For example, let me take a pointer here. So when you form the groups, what happens is, either you can take this as a single group. Okay, but if there is a possibility for a bigger group, you have to give a priority to the bigger group. So what will be the bigger group here? This can be a bigger group here, the consecutive ones together. Okay, and even bigger group is possible, which is the this one, right? See, this is an even bigger group, right? And if you take a group of 8, that is also possible. A group of 8 will be as follows. Okay, this is what a group of 8 will look like. And a group of 16 means all of them should be 1, then it is a group of 16. Okay, so in this case the maximum group we can form here is of 8. So this is one group here, 8. And another group what we can form, another group of these ones are there. So another thing which you need to know is that we can form groups uh, through the end of the rows also. Okay, like for example, this can be one group. Okay, 4. Okay, just think it as a connected, like a cylinder. Okay, this whole thing, if you put it on a paper and roll it, how it will be, it will be like this in the form of a cylinder, right, where it is ones and zeros are present there. Okay, see, this will be this one value will be present here. Sorry, let me take a normal pen. Okay, see, if you put this on a sheet of paper and roll it, what will happen, this end will be connected with this end, right? So if these both ends are connected, in that case how it will look like, if it is a in a roll of paper, the first column will be this one, 1 1 1 1. Okay, this is the first column here, and the end column will be here, 1 1 1 0. Okay, so see, in this case still you can form one group here, right? So this is what I'm talking about, that you can form a group through the ends. Okay, so what are those possible combinations through the ends? Either you can form through the ends of the columns. Okay, like you can form through the end of columns like this and like this, or you can form through the end of rows like this and like this. Okay, you can either take single or you can take double or you can take both of them, either you can take. Okay, and you can even form a group from the end of the four cells. If this is one, this is one, this is one, and this is one, you can still form that as one group. Okay, so this is how you form groups. And once you have formed the group, you have to form the maximum group. Okay, so what are the maximum groups that can be formed here? Let me take the maximum groups. So one maximum group can be this. Obviously it is having 8 values here. Okay, this is one maximum group. And second maximum group can be taking 2 values from here and 2 values from here. And another maximum group can be taking 2 values of here, none of them should be left out. Okay, and 2 values from here. Okay, these are the three groups which you can form using the K map. Okay, so let's take one by one group. Okay, so the first group which you can see here, it's a combination of 8 values here which are present, and these 8 values have formed a group. After you have formed a group, what you have to do is you have to write the values which are present here as 0 0 0 1 1 0. Okay, so let's take it one by one. Okay, how many groups are there? There are totally 3 groups. Okay, 3 groups are there. For simplicity purpose, we will be taking one group at a time. Okay, so what is the first group you can see here? The first group is this group. So what you have to do is you have to write the numbers associated with each cell. Okay, let's take the first cell for example. So what are the numbers associated with the first cell? It is 0 0 0 0. Okay, and the second cell is 0 0 0 1. Okay, so we'll be writing 0 0 0 1. Then we'll be writing 0 1 0 0. Okay, 0 1 0 0, and here it will be 0 1 0 1 0 1 0 1. Next will be 1 1 0 0, and it will be 1 1 0 1 1 0 0 0, and 1 0 0 1. Okay, now since after you have done this much, all you have to do is you have to observe which cell is getting changed. Okay, you have to observe which cell is getting changed. So see the first column here, is it getting changed? Yes, it is all 0 and it is 1 here, so we have to not consider this one. Okay, put an X on top of that. And sorry, let's make it in a simple way. So this is these numbers are associated with wxyz, right? Wxyz. Okay, whichever is getting changed, don't consider it. Okay, so this is getting changed here, don't consider it. 0 0, this is also getting changed, don't consider it. This is all same, so consider it. Consider it, just keep it in your mind, we are considering this one. And z is getting changed, we are not considering it. So what do you mean by considering? Considering means since 0 is here and y is getting considered here, you have to write it as y not. You understood why I'm writing not? Because it is 0 here. Okay, and since all of them are same here, we have to consider that. So it is why not. So the answer of this whole group is why not. Okay, just remember it. Next, what group we have? Next group we have this one. Okay, let me erase the first one here. Now the next group we have is this one. Okay, these two and these two. Okay, it can be formed only of a four, so we are taking these two. Now note down the second group's numbers. Okay, so what are the second group's numbers here? The first set is 0000, write it 0000, 0100. Okay, in any order you can write 0100, and here it is 0010, 0010, and the last one is 01 and 10, 0110, 0110. Okay, now observe which numbers are getting changed. Okay, for simplicity purpose, let's write wxyz. Is this getting changed? No, we have to consider this one. Okay, is x getting changed? Yes, one is present here. Y getting changed? Yes, one is present here. Z is getting changed? No. So consider y and w and z. And since it is both has zeros here, you'll be writing w bar z bar. Okay, this is the value for the second group. Now for the third group. For the third group, it was the third group. Let me erase the second group and let's take the third group. So what is the third group present? The third group is the one in the middle, which is the following. Okay, what are the numbers associated with the third group? Here let's write the numbers w, x, y and z, and 0 1 0 0, and this is 1 1 0 0, 1 1 0 0, and this is 0 1 1 0, 0 1 1 0, and this is 1 1 1 0. Okay, 1 1 1 0. Okay, now observe what is getting changed here. Since w is getting changed, 0 and 1, you will not consider this one. X is not getting changed, it's entirely one the whole column, so we'll be considering x here. And y is getting changed, z is not getting changed, we'll consider z also here. Okay, now observe in x it is 1, so we'll be writing it as such, x as 1 only, and z is 0 here, so we'll be writing z bar. Okay, so these are the three equations we have obtained, and these are the final equations which you have to write in the form of function. So the final function will be equal to, just add up these three equations. Okay, so final value will be y bar plus w bar z bar plus x and z bar. All right, so this is the final equation for the given question. This is how you solve it using KMath. Okay, it's very simple. The first thing you have to do is take up the 2D matrix for it and write down w, x, y, z, and write down the values here in the gray code, and after that fill one wherever it is the numbers which are given here. How you'll write this one? You'll write m0, m1, m2, m3, m4, m5, m6, m7, m8, m9, m10, m11, m12, m13, m14, m15. Okay, so this is how you write all these values, and you will be making the groupings as well. And after you make the groupings, you'll be able to means after you have grouped all of this, then you'll be writing the equations, like considering or not considering the values by using this thing. And wherever it is not getting changed, you have to consider that. If it is 0, you'll be writing a bar at the top. If it is 1, you'll be writing it as such, and after that you will be adding up the three equations. Okay, this is how you solve a question using K. Let's move on to the next topic, which is prime implicant. What do you mean by prime implicant? So prime implicant is the all the possible groups which you can form. Okay, like for example, if you take this one here, the first group is this, second group is this, third group is this. Okay, so three groups are formed, right? So these three groups are prime implicants. All the groups which can be formed in a K-map, that is called as a prime implicant. Essential prime implicant is the one which is not having redundancy. Okay, since this is covered by this group and this is covered by this group, we cannot again take this one, that will be redundant because it's already covered. Okay, at least one of them should not be covered, then only we can take it. Okay, so essential prime implicants are two only. Okay, we have to remove the redundant ones. Next we have the don't care condition. Don't care condition is a variable value denoted by x in a K-map. Like we have 0 and 1, we have a x here, and x can either be 0 or 1, and it's upon us, we can use it or we cannot use it. Based on if you use it, is it more simplifying, or if you don't use it, it's more simplifying, and so on. Okay, so for example, if you have been given a question like this, it's a very important question. Simplify the Boolean function. You have been given f and d here. What is d? D is don't care conditions, and f is the normal ones, okay, which has the values, true values, okay. So first we'll be making the 2D matrix here, and the minterms are 1, 3, 7, 11, and 15. So these are called the minterms, okay. And after we have written these values, we'll be making the kmap and writing 1 wherever these values are there, 1, 3, 7, 11, 15. So 1, 3, 7, 11, and 15, all these values will be marking it as 1. After that, we have to mark the x values. X values is given by d. So 0, 2, and 5 cells that are marked by x, 0, 2, and 5, okay. So this is 0, this is 2, and this is 5. Both these are marked as x. Now it's upon us, we can consider x as 1 or x as 0, okay. Based on that, if you are considering it as 1 and getting a more simplified equation, we'll be considering it as 1. If you are able to get a more simplified equation by considering x is equal to 0, we will be doing that, okay. Or if we choose not to use both of these, that's also fine, if you are getting a more simplified one by not choosing them, okay. So in this case, we can get two equations by considering x as 1 and not considering x as 1. So suppose that I consider this x as 1 and this x as 1, a group will be formed here, and this group is obviously present here, right? So there are two groups formed, and by using the same formulas, like writing down the numbers, cancelling, and considering, and then getting the equation, we'll be getting these two values, okay. Yz is for I'm not sure, this is the yz, and this is the w dash x dash, okay. So this is one of them, and in case we consider this one, this x as 1, in that case this will form a group, and not considering these ones, and this one will be ones present here as usual. So these two equations will, if we combine, we will getting this equation. Both of them are valid equations, and this is how you use the don't care conditions for simplifying it further, okay. Next topic we have is the NAND and NOR implementation. NAND gate, you remember, right? The opposite of AND gate, and OR gate is the means the opposite of OR gate is the NOR gate. Okay. So we have the NAND implementation here. So we have to implement the Boolean function f is equal to ab plus cd using the NAND gates. Okay. We have to use the NAND gates to implement the following equation, ab plus cd. Okay. So how you will be doing that? First, draw the normal circuit. Okay, you have been given this question and you have to do it using NAND gates. What you'll be doing, first form the normal equation. How do you form the normal equation? The normal equation can be formed by writing all the inputs. How many inputs are there? A, B, C, D. 4 inputs are there. Take 4 inputs A, B, C, D, and this is the AND gate here. This is the AND gate here, and when you will be passing it here, and you will be passing it here. So what happens? AB plus CD will be there. Okay, so this is AB and this is CD. Both will be going into the AND equation. So this is AB and this is CD. Next, what is happening? It is an OR operation present here. So we'll be writing like passing it here into the OR gate. So the final equation will be AB plus CD. Okay, AB from here and CD from here. Okay, this is how you break down it into the simple steps and then form the circuit of it. Okay, what's the next step? Since we have to use only NAND gates, and this is not NAND gate, this is not NAND gate, and this is also not NAND gate, you have to convert this into NAND gates. Okay, for converting, we will not directly convert. First we'll convert into NAND and NOR gates. Okay, whichever is AND gate, if we have to convert all the AND gates into the NAND gates, and we have to convert all the OR gates into the NOR gates. Okay, if you observe here, this AND gate will be converted to NAND gates, and this OR gate will be converted to NOR gate. Okay, so see, this is the NAND gate, and this is the NOR means NAND gate you have converted, and this is the NOR gate you have converted. Okay, so this is how you form the equation. After you have done, like also you have to put a bubble before this one. Okay, after you have done this one, convert the NOR gate into the NAND gate. Since these both are valid conditions where we have the NAND gates, to convert the NOR gate into the NAND gate. Okay, so this is the NOR gate. Just convert it into another NAND gate. Okay, that's what. It's very simple. You have to just convert the NOR gate into a NAND gate. So in this equation, all of them are NAND gates. Okay, and if you simplify this equation, you'll be getting the actual equation which was given in the question, AB plus CD. Okay, you can verify it by using algebraic expressions. Okay, so this is the step-by-step procedure. First you have to convert the AND gates into NAND gates, and then you have to convert the OR gates into NOR gates, then you have to convert the OR gate into I mean the NAND NOR gate. Okay, NOR gate you have to convert. See, first you convert the AND gate into NAND gate, and then you will be converting OR gate into NOR gate, and NOR gate will be then converted to NAND gate. Okay, this looks like a redundant function, but that's how you follow the steps. Step by step you have to do. Okay, not all at once. Next we have the another simple question, which is again the NAND gates you have to use to simplify the following equations. Either they can give you in this form, or it can give you in this form only. In case they give you in this form, first you have to use the K map and find out this equation, then proceed. Okay, that will be for higher marks. But here in this case, the direct equation is given, so you'll be using this same equation here. Okay, so draw the normal diagram. This is the normal diagram which is present here, and here what we will be doing, x y bar and x bar y and z here. Okay, so x and y bar here. Okay, so x is here and y, it will become a bar here, and this will be x y bar, x bar y. This is x bar and this is y, so it will become x bar y, and this z will be as such here. Okay, so the inputs you have taken here, and found the three terms, x y bar, x bar y and z, and after them all are getting OR here, so it will be passed to an OR gate here. Okay, this is the normal diagram. Sorry, this is not okay, this is a normal OR gate. Okay, not an OR gate. Okay, fine. Okay, next, after doing this much, what you have to do, you have to convert the NAND gate into the NOR gate. Okay, I mean the AND gate into the NAND gate, and you have to convert the OR gate into the NOR gate. Okay, so how do you do that? And also you have to remove the NOT gates. In final equation we don't have NOT gates, so directly you can take this as y bar and this as x bar. Okay, as it's shown here, you can directly take it as y bar and x bar here, and convert the AND gate into the NAND gate, and then convert the OR gate into the NOR gate. The next topic we have is the NOR implementation. So what do you mean by NOR implementation? You have been given with an equation. We have to use only the NOR gates and do the substitution. Okay, so that's how you will be doing the NOR implementation. Okay, so this is the equation given: f is equal to a plus b c plus d into e. Okay, and convert the NOR gate circuit to convert into the NOR gates. Cool. Okay, so first draw the normal circuit which we have. These three are AND, so it will go into the AND equation here, and this will be the OR operations present here, and we'll be getting a final equation here. Okay, and convert all the OR gates to the NOR gates. Okay, and convert all the AND gates to the NAND gates. Okay, so this is what we have to do: convert OR gates into NOR gates and AND gates into NAND gates. Okay, so since we have been doing that previously as well, it's very simple, but the bubble will come after this one, and here it will come before this one. Okay, cool. After you have done this much, you will be having to convert into the NOR gates. Okay, just you have to use the NOR gate. So finally you will be converting the this gate into the NOR gate. Okay, just a simple NOR gate you'll be converting like this. Okay, that step I forgot to write, but that's how you'll be converting it. Okay, next we have the last topic, which is the HDL, hardware description language. Okay, so what is HDL? It's similar to the normal programming language such as C, and it is used for the Boolean algebra and logic. Okay, we'll be having this language for the low level programming. Okay, so we have to understand and execute the HDL. For that we'll be using the Verilog. Okay, it is the framework which we'll be using. Okay, so in that there are three types of modeling. The first is the data flow modeling, second is the behavioral modeling, third is the structural modeling. Okay, so data flow modeling describes the system, how the data flows, and the behavior describes how the system's behavior or function changes. Structural modeling is in the terms of structure and interconnection between the components. Okay, now an example for each of these modeling, very simple. So write a Verilog program for the OR gate. You remember what is an OR gate? So the OR gate will have the value as 1, either of them will be 1, right? So it's very simple. For the data flow model, you will be writing module data flow. Consider A, B and Y. A, B are the inputs, Y is the output. So what is the input? A, B is the input, output Y. You'll be writing like this, and then you'll be writing assigning Y. Y should be what? A or B. So this operator here, this operator is called as an OR operator in the programming language. Okay, then you will end the module. This is called as data flow module. Okay, next we have the behavioral module. Here also we'll be taking the three inputs, I mean two inputs and one output. So input A, B, output Y, and reg Y. Reg Y will be writing here register as Y as always at A or B. Okay, register Y means the value of this should be registered in the Y. Okay, A or B, and if A is equal to 0 and B is equal to 0, then only Y is equal to 0. Okay, else Y is equal to 1. Fine, this is, we are defining it here, and we are defining the value here. If A is equal to 0 or B is equal to 0, then Y is equal to 0, else if either of them is 1, then it is 1 here. Okay, that is the data flow behavioral model. And the last one is the structural model. Here we'll have a, b, and y, and input will be a, b, output will be y. And here we'll be writing GLYAB. Okay, GL is the term used for OR operation. Okay, YAB. Then we'll be ending the module. This is how you'll be using the structural module. Okay, that's all in the first module of DDCO. And if you found this video helpful, make sure hit the like button, subscribe my channel for more videos like this. And thank you so much. I'll see you in the next one.